morning, everyone, and thanks for being here. My name is Mattia Zeni. I'm a R&D in Tomtom, and this talk is about how we use data and AI in Tomtom, basically to transform mobility. So, who knows what Tomtom is? So who have ever seen or used one of these devices? Raise your hand. Good. So Tomtom was famous for this little thing over here, so PNDs, portable navigation devices. We sold a lot of them. They were so important that the Computer History Museum decided to give us a slot in their catalog. You probably noticed that today not many people use them. So with smartphones, there was a switch from this to smartphone and other technologies. So also Tomtom had to switch. So we are not anymore B2C, focused on B2C with these devices, but we are something else. And this is what Tomtom is about today.
This is Berlin, the free-thinking home to some 4 million individuals, 1.3 million cars, 500,000 cyclists, light rail, buses, and, well, this thing, all trying to reach their destinations and overcome some pretty challenging traffic. Or in short, the perfect home for Trillian, Tomtom's very own self-driving test vehicle. But before Trillian is set free on Berlin's streets, she has to go through some serious testing. First up, flexing her driving algorithms on an open stretch of asphalt. Then, driving through a controlled environment, full of obstacles. Well, heads up. Now Trillian is ready for Berlin's traffic, as long as she's accompanied by trained safety operators, like Manuel here, who can take control if needed, and Manuel's sidekick, who closely monitors the car's status and what she's sensing. When everything checks out, Trillian goes into full autonomous mode. Driving with full autonomy, Trillian goes through as many traffic scenarios as possible, all thanks to the speed and precision of Tomtom's HD map. Trillian uses Tomtom's HD map to know exactly where she is and what's around, so she can safely plan her path through traffic or around it. Tomtom AutoStream continually delivers an up-to-date map from the cloud, processed with accuracy, speed, and efficiency. Because Trillian needs to think faster and smarter than everyone else on the road. After every drive, Trillian sends data and insights to her autonomous driving development teams, testing Tomtom technology for any purpose in any car, to help self-driving cars hit the road sooner in a safe, connected, autonomous world.
All right. So as you could see, the company changed its core business, so we're not, as I said, B2C anymore, but we are more on a B2B side with a broader, so we want to focus more on a broader spectrum of solutions related to location technology in general. So specifically, the company is working on these three, so we call them the three pillars. So you see autonomous driving with software and maps designed for autonomous vehicles to help OEMs deliver their self-driving cars. Then there is another pillar which is about connected vehicles, which means basically online navigation, which is basically software again and maps in dash systems, in cars, but also mobile navigation. And finally, there is a third one, which is related to smart mobility. So a whole set of services provided through our APIs. What is Tomtom vision today? So the vision is a safe, connected, autonomous world free of congestion and emissions. So our focus, as you probably noticed, are drivers, mainly car drivers, but not only. We want them to be safe, to be connected, so to have real-time information when they drive, so that they can have a better driving experience. Autonomous is there, so that's the next big thing in the auto industry. And we are part of it. Then this world we envision should be free of congestion, because traffic is a problem, and free of emissions, so electric vehicles and really get rid of fossil fuel. Why we want to do so? Because there are some statistics that are not really good, like this one, which says that every 25 seconds a person dies in a car accident, or this one, which says that 28% of global warming is caused by transportation, not only private transportation, but still. And the fact that congestion are really a problem today. So there's this statistic that says that an average New York City driver really wastes a lot of money every year being stuck in congestion because of time loss or the fuel he consumed being stuck in traffic and so on and so forth. So what's the mission then starting from this vision? So what we want to do is to create the most innovative technologies to help shape tomorrow's mobility. And how we do so? We want to do so using data and artificial intelligence. And that's why I'm here to talk to you today. So as any company, business value is the key. So we want to create business value. But we want to do so starting from data. So we want to take data-driven decisions. And we want to do so exploiting artificial intelligence. So as you can see from this image, really the core is the data. So we need to start from data because that's the key for data-driven decisions. And in Tomtom, we sit on a huge amount of data. And actually, data is the foundation of everything we do. We have a huge community of users which send us the so-called probe data, so GPS traces. But of course, when you deal with user data, you have to be very careful about privacy, especially nowadays. Well, with GDPR in 2018, but so it's not only a legal aspect, it's really an ethical thing. We want to do it in a proper way. And in Tomtom, we only care about where you are now and where you want to go. We are not an advertisement company, so we don't sell your data. We use our data. We use the data only to improve our services. So there are three very important aspects here related to privacy. Of course, the user must be always informed of what we collect and what we do with that data. The user must be always in control of its own data. And finally, the company must guarantee, must protect this data at any cost. So in these slides, I'm going to give you a picture of what I'm talking about, so how many data we have. So in total, we reach up to 800 million drivers with at least one of our services, which can be maps or traffic or navigation and so on and so forth. And this is 40% of worldwide population, so really we have a good sample there. These people, the amount of data they send us is 3.5 billion kilometers per day. So it's really a huge amount. They send these GPS points that cover 3.5 billion kilometers. Yeah, so this is 54 times the global world network, if you're interested. So what are the sources of this data? I've been talking about community, but this is not the only one. It's the most important one, but it's not the only one. We have also mobile mapping, satellites, news feeds, and web. So in the next slide, I'm going to go through each of them briefly to, again, make you understand what I'm talking about. So as I said, we have 800 million people that use our services. This translates to 600 million devices, because most likely some devices are shared. So we have this amount of devices that send us data. And yeah, this is 30% of worldwide driver population. This is not the only one. So in this case, what the people send basically is an anonymized stream of GPS points. So latitude, longitude, and timestamp. We have other sources, as I said, like mobile mapping. So we have our own nice cars that go around. With these cars, we are able to map 3 million kilometers a year. Of course, data we can collect here is much richer than the previous case. So in this case, we have, so the car is has a 360 camera on the roof, which takes picture. It has LiDAR to take 3D maps of the road and the surroundings. of course, as GPS. So the amount of data here is 1 terabyte per day per car. So really big data. Satellite, of course, for some specific areas of the world, we use satellites to map roads where, for example, the car cannot go, or where the update frequency we need is higher than what we can cover with the cars. We also process other types of data, for example, news feeds, so that to update the traffic, real-time traffic services. For example, if a municipality knows that this week in Amsterdam there is a big event, which is the case, we can explore this information and adapt the maps accordingly. We also started doing some web scraping on social networks, for example. So if a guy is stuck in a traffic jam somewhere, we can detect that and theoretically update the map as well. So really, we are talking about a huge amount of data. This is a nice picture that shows, so it's a neat map of all the GPS points we collect from all these sources of data, mainly community, because that's where the GPS points come from, on a year. So you can see the coverage is pretty wide. It's almost the whole world. So as I said, we use this data to improve our services. And the first example that comes to my mind is traffic. So we have one of the best traffic services in the world. So it's updated every couple of minutes, I think 3 to 5, on a global scale. So what you see in your TomTom navigator is really an updated snapshot of traffic worldwide. And this is computed using this data. Yeah, so this couple of years ago, we launched this service called Traffic Index, which is basically, it takes a snapshot of the previous year traffic situation in the biggest city in the world. It's nice if you want to go on the website, it's freely available, you can check. I just downloaded this, took a screenshot of Stockholm 2 days ago, and the traffic is pretty good here. So, what is the recipe to do what we do? The recipe is data science and basically artificial intelligence. So the idea is you start from data, you apply data science, and with this you take data-driven decision, which basically improve your product. So you end up having better products. And this, of course, brings more users, and then business value. So this is linked with what I said before. But also more users bring more data. So this is really a loop. So you start getting more data, more users, more data, and so on and so forth. And that's what ideally any company should achieve. Yeah, artificial intelligence, I bet there are 100 different definitions, and in this room, for sure, there are 10 different. Yeah, so basically, with artificial intelligence, I'm referring to any form of intelligence that a machine shows when it has to perform a task for which it was not explicitly programmed for. So the machine is learning and can solve new tasks. I think the term was born in the 50s, around the 50s, but then everyone who is talking about machine learning, especially from the 80s on, is really, about artificial intelligence, is really referring to machine learning. So this idea that you have kind of a black box, let's say, where you input data and you input the expected output. The machine is able to learn from this, so you didn't actually code the software to do some task. So the machine is able to learn, and then when the machine is shown a new value, is able still to produce a result. So it's able to generalize. But then, in the last 15, 20 years, when people refer to AI, usually refer to deep learning. So if you go to an academic conference, when there is deep in the title of a paper or a poster, everyone stops because everyone is really interested in deep learning. Which in the end is a subset of machine learning, right? So in this talk, when I'm referring to AI, I'm referring to all of these. So machine learning, deep learning, we do a bit of everything in TomTom, depending on the use case, of course. So what I want also to highlight is that we don't have to use machine learning for any tasks. Maybe some tasks are easier just creating an algorithm. So when should we choose when to use a human-coded algorithm with respect to machine learning? For example, when the rules are quite clear, like in this nice picture over here, a bunch of software engineers can really create a piece of code that performs the task. So they can, it can take an input and do some processing and create an output. So this is still the case for most of the routing problems and algorithms today. They are just based on heuristics and human-coded algorithms, even though we start moving to deep learning also for this. The alternative, is to use machine learning. So the problem is very complex, so you can't really find rules in the data, find patterns, or the dimensionality of the data is very high, so that you can just create an algorithm. So you use machine learning. So you give an input, the expected output, the annotation basically. The machine learning does its magic, creates a model, and then you can provide new inputs to generate output. In Tomtom, we use AI, so machine learning, deep learning, in different elements. One specifically for deep learning is the maps. So when we create our maps, we need to automatize the process, and we use deep learning. So this is basically the history of maps in Tomtom. So we start from the first map, this one, which was for humans. Then we move to live map, which is a map that has some real-time features like traffic. Then we move to ADAS map, which has other interesting features like speed limits, position of different elements. And finally, we move to HD maps, which basically are what Tomtom is focusing on for autonomous driving. So our product there is HD maps, so maps designed for machines. These maps are very accurate. So we can map the road and anything on the road with a 2-centimeter accuracy. So we know where lane dividers are, traffic lights, traffic signs, poles, trees. Because we believe that an autonomous car needs to know this information to work properly. They cannot just rely on cameras. Then the problem is we need to update this very often, because if a car is leveraging this information, we really need to update it very frequently, otherwise the map would be outdated. For this reason, some teams in Tomtom, specifically in autonomous driving, are using deep learning. So one of the tasks they had to perform is domain adaptation. So basically, we collect data from, let's see if this thing works. Yes. We collect data from our cars, as I said before, these two pictures. And the idea is, we have a lot of those images. We can really train our deep learning models to recognize elements on the road. But then what happens when the conditions are different? So like if it rains or if there is snow. We don't have enough images about that, and it's very costly to send out cars in those conditions. And it's also kind of dangerous if it snows and we send out all those cars. So the point is, this team in autonomous driving wanted to be able to generate new training material, let's say. So they used generative adversarial networks to convert the images we have to new images. So like the one on top there should be a snowy situation, while the second one adds some rain. There is also another scenario for which we use this approach, which is this one over here. Basically, we have simulators to test our solutions, and with simulators, we can drive a lot of kilometers automatically. So you just set up the scenario and it works. But then, of course, you cannot create on these images. You clearly see that this is a video game. Instead, what I want to do is to try to translate this to a real image, so that we could really train on top of it. Another application related, again, to image recognition using deep learning and GANs was about the detection of lane dividers. So up to some months ago, this was done manually by a bunch of people that were looking at all these images and annotating. So these are the classes of the road that we have to map. Okay. So there are 29, so a lot of classes, and the process is really, does not scale, it's not able to scale. Instead, the idea again here was to use GANs to be able to detect this automatically, to detect all the properties and all the different classes. So we have this in production already for highways, where the situation is simpler, but not really. So in this video, for example, you see a comparison about human annotator and this approach based on GANs. So you can see, okay, in a highway it's pretty easy, everything is straight, but then we start having junctions and other type of elements on the road, so it can be tricky as well. So at the moment, this system works pretty well on highways. We are working on it to make it work in a urban scenario where there are much more junctions, so the problem is really more complicated. The nice thing of this is that it's completely automatic and it prints an accuracy. So if the accuracy is below a certain threshold, we can trigger, for example, a request to a manual annotator who can fix the thing. And this really saves a lot of time. All this is done to create HD maps. We have another example. So another team in autonomous driving. So this is more academic work. So they basically created this new framework called LGAN, which basically uses generative adversarial network for the semantic segmentation problem. But the idea is that they wanted to do it in a supervised fashion. So they wanted to enforce structure into the data, for example, to recognize lane dividers. So not doing it in a pixel by pixel basis, but instead enforcing some rules. You can go and check the paper if you want. So this is an output, a video of this system in place. So the upper left corner, you see cars, and there we want to recognize these cars. So we have a bounding box around cars in real time. The screen over there instead is about highlighting lanes, lane dividers, and elements on the road. And you can see it's pretty accurate, because even in this situation, you cannot really recognize it if you look at it. This one instead is about recognizing vertical elements like traffic lights and traffic signs. And this, in the end, is the output of the semantic segmentation task, which is really nice and colorful. So, but we don't only use deep learning. As I said, we also leverage on machine learning. So this is a project I personally worked on. So the idea was, can we personalize the driving experience of the users? The answer is yes, we can, but in which aspect specifically? So we understood that ETA, so the estimated time of arrival, is a quite important parameter people use. So maybe you know where you want to go, so you don't use turn-by-turn navigation. But even if you know your route, you want to know the time at which you will arrive at your destination, because this is really unpredictable. It depends on weather, traffic conditions. So this is a feature that many people use, even if they don't use turn-by-turn navigation. And there is a there is an aspect which is related to personalization that really affects this parameter. So if you are a rally driver like this guy, maybe you arrive faster than me, which I'm this kind of driver with the 500. So the idea is we want to push for hyper-personalization in the driving experience, because really it makes a difference. So we proved that we can improve the accuracy by 15%, which on 1 hour is 10 minutes, which is kind of a lot. So the idea is we want to use features like if the person previously drove on this road, or if how the person historically drove on roads similar to this, like on highways. So this was a nice project that we had to. So an OEM was interested on it, and yeah, it doesn't work. So yeah, basically the process we had to do to make this project happen is there are two. So per processing, which when you deal with maps and localization means map matching. So basically, you have this huge bunch of 100 million GPS coordinates, and you have to put them on a map. And it's not an easy task because basically you have to filter out outliers, so GPS coordinates that are not accurate, among other stuff. Yeah. So about the analysis, we used basically like GBM, so quite simple algorithm and lightweight on 900 drivers for basically we analyzed 47,000 trips for a total of 17 million road segments. We did so you can briefly see it, in Europe. So this customer was interested in the UK, Netherlands, and Germany. And we had a good coverage there. And then they were interested on some areas of the US, basically East California and Florida. Yeah, this should be Europe. And yeah, so basically these are some use cases I decided to show you that present how TomTom is really a company based on data and on AI. And we try to enforce these practices all over the company. So we have trainings, we have events that really are used to gather together people that work in data and artificial intelligence in TomTom. So I have a nice video if this works and helps me out. Yeah, anyway, so it's a video showing an event we had at the beginning of this year. It's almost the last slide. All right, so yeah, the presentation is finished anyway. So I had one last slide, which was about Tomtom API. So if you're interested in this stuff and you want to use it in your own projects, there are Tomtom APIs available with a free tire for every day on a daily basis. If you want, we can extend that. And yeah, that's it. Thank you.